Assalamualaikum. My name is Nurul Asnida. Okay, so here I want to talk about differentiation. What is differentiation? Okay, in a simple way, we can understand that differentiation is the derivative of the instantaneous rate of change of a function with respect to one of its variables, or differentiation is a process of finding the derivative or rate the change of a function. Okay, so have you ever wondered why we use differentiation? Did you know that differentiation and integration can help us solve many types of real-world problems? We use the derivative to determine the maximum and the minimum values of a particular function. Example like cost, strength, amount of material used in building, profit, loss, and else. Okay, so we basically took a function y is some function in terms of x, and then we learned that there was a process called as differentiation to find the derivative, we call as dy dx, or maybe we can write it as a function prime like this. Okay, so what is it that we have actually done? Basically, what we have done there is found the rate of change of a function. The rate of change is just simply given by the gradient. Okay, so if we had a curve, we could find the rate of change by just look at the tangent, and here is the tangent. So the gradient is in the other word for the tangent.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fitri binti Muhammad Ali and my group's name is Girl Gang. So today we want to presentation for you. The topic is application of differentiation of conical water tank. So I just to present for you the subtopic is what to solve from this question. So first of all, let's see the question first. A conical water tank has 16 cm height and a radius of 4 cm is being filled at a constant rate of 8 cm³ per second. How fast is the height changing at an instant when the height of water 12 cm? So next from the question, we can know that the height, the radius and the dividity. Dividity that means rate of change in volume with time. Also the rate of change have three types. It is rate of change in area with time, rate of change in volume with time, and rate of change in radius with time. So I want to show you the formula. So next, I want to tell you about what we want to solve from this question. Okay, from this question, we want to find the DHDT. The DHDT that's mean rate of change in height with time. So I want to show you how to find the DHDT. So let's go to the next subtopic. It is how to solve the question.
Okay, we start by drawing the picture of cone. We need to recognize the information given. The height of the tank is 16 cm and the radius is 4 cm. This is the formula since we have radius and the height, and we will use formula of volume. Next is the rate is constant at 8 cm³ per second, which is dVdt is equal to 8. The question is, how fast the height change when the height of the water is 12 cm? That means the rate of the change of the volume is dHdt is unknown. To find the volume of the water, we need to find its radius first. Draw two triangles represent the height and radius of the tank and the water. So 4/16 equal to R over H. Let R alone in front and move H at the back, and we get R equal to H over 4. Then we can find the volume by substitute R into the formula V equal to 1 over 3 pi h over 4, which is R squared multiplied by h, and we will get pi h cubic over 48. Differentiate the volume because all about the rates. dV over dh equal to 3 multiplied by h squared over 40, and we will get pi h squared over 16. Lastly, we will find the dt by using chain rule and substitute all the information we got. dV over dt equal to dV over dh multiplied dh over dt. Substitute dV dt, which is 8, and dV over dh pi h squared over 16. Then, in the h of dV over dh, we need to substitute 12. And the last answer will get 8 over 9 pi. The conclusion is the water will rising 8 over 9 pi centimeter cubic per second fast when the water is 12 centimeter height